All right, so we're 1 minute past, so I feel like we can get started now. Hello, everybody. Welcome to today's webinar on high availability server architecture. We appreciate you taking the time to join us today. We know that your time is valuable, and I am truly thankful for everybody's attendance today. In our mission critical landscape, agencies utilizing a dispatch console rely heavily on what we know as a hot standby redundant system to ensure operational continuity in case of failure. What we will be discussing today is an approach you may or may not heard of called high availability. With high availability server architecture, it's a component of our Enlite Cloud Ready Dispatch console system. This design ensures your deployment is always up and running and minimizing downtime. In this webinar, we will explore the fundamental concept of HA server architecture and its importance in keeping your client systems running efficiently and making sure that that PTT button is always working for you. We will also discuss the approaches to building an HA server architecture, including clustering and load balancing. By the end of the session, we will have a general understanding of how HA server architecture will meet the unique needs of your customers. And once again, thank you for joining us, and let's get started today. We're going to start off with some introductions. James, would you like to introduce yourself?
Yeah, so my name is James Birchall. I am the technical lead for the Enlite product. I've got about 20, 25 years of experience, depending upon when you want to start counting, in industry with all sorts of experience with data center stuff and embedded systems, and now radio systems and critical communications.
Thank you, James. And my name is Nick Blackmore, Sales and Marketing Coordinator with about a year and a half experience so far. So still a little green, but like I said, we're going to have a great presentation today. So we're just going to quickly go over today's agenda. Today we're going to cover what is high availability and why it would matter to you or your clients in regards to their dispatch console system. We're going to discuss the differences between high availability and disaster recovery. We're going to go over the benefits of using the cluster architecture. We're going to also evaluate the elements of high availability, go through the failover sequence of both high availability and just a quick review of hot standby. We're going to also look at the types of Enlite high availability deployment methods. Then we'll end up with a conclusion and some time for a Q&A session at the end. Now, this is where I just get into the housekeeping stuff. We're going to save the questions to the end, but if you see at the bottom of your screen, you have a little Q&A button where you can actually submit questions throughout the webinar that we can get to at the end, or if you just place it in the chat, we'll also look through there. So starting off, we're going to answer the question, so what exactly is high availability? Well, in the simplest terms, high availability is the ability of a system to operate continuously without failure for a designated period of time. High availability works to ensure that the system meets an agreed upon operational performance level. In the dispatch console industry, mission critical operations performed by a dispatcher, such as those undertaken at a public safety answering point, require continuous secure access to the radio and telephony resources to ensure they can always answer the call effectively. And how is HA measured? Well, high availability is often measured in the percentage of time that a service is available to users. This is done by dividing the total uptime of the system period, which is then multiplied by 100 to get a percentage. The use of high availability architecture allows for less barriers to reaching these goals. As you can see at the top of the table, we have 5 nines reliability shown. This availability metric shows that in a span of a year, that system cannot have downtime any more than around 5 minutes, which is a very small amount. As part of disaster recovery planning, you need to define an RTO and an RPO for each application based on impact analysis and risk assessment. So what exactly is an RTO? RTO is the maximum acceptable delay between the interruption of an application and the restoration of its service. This objective determines what is considered an acceptable time window for an application to be unavailable. RPO is the maximum acceptable gap between the data in the disaster recovery site and the latest data stored in the application when a disaster strikes. This objective determines what is considered the maximum amount of time acceptable for interruption/loss of data that can be caused by a disaster. Fundamentally, high availability and disaster recovery are aimed at similar problems. keeping systems up and running in an operational state, with the main difference being that high availability is intended to handle problems while a system is running and continue to offer availability to the end user, while disaster recovery is intended to handle problems when a system fails, regardless of how highly available the system is. And if it's okay with you, James, I was just wondering if you could speak to this table here.
Yeah, sure. So one of the things that we really encounter when we start talking about high availability is this notion that it's always available, right? And the answer is yes, it is, as we measure it. But then we have the circumstances where, for whatever reasons out of our hands, this is our disaster categories. This is an exception to our availability, right? So it's crashed, it's broken, the site has been blown up in a nuclear disaster. Um, and so what we have is really kind of our restoration processes. So in disaster recovery, we have our recovery time objectives and our recovery point objectives, which are defined when we build a system. And they're really about the backup period, right? So how often are we taking backups? And then once we have a backup, how often or how long does it take to restore everything from zero, right? So it's not about what happens if one node goes out or two nodes go out. So in this case, a disaster under an old architecture, the hot standby is both sites are dead, right? If we have, the bunker mentality where we have kind of a radio vault and a radio bunker where it's like really, really tough, what happens if that site, for whatever disastrous reason, is gone? Right? Then we have to restore or move everything to a different place. One of the most common problems in disaster recovery is what we call the poison pill, right? So this is an entry in a database that deletes all the data in the database, right? So if you have just replication and high availability, that zips from one side of the system to the other very quickly and destroys all the data. So now we have to recover. Our availability, we talk about in some components, in our subcomponents of our reliability, our mean times between failure and our mean time to recovery. So this is really thinking about the node, the single element that fails. How long until it's likely to fail? And then once we figure out how long it's likely to fail, how long does it actually take to replace it when it does fail? Does that work for you, Nick?
That is perfect. Thank you so much, James.
Woohoo!
So the big question is to everybody here, why would high availability matter to you? Well, let's say you have a client and a public safety dispatch requires that PTT button to always work. There can't be downtime in regards to that. Lives are on the line. Computers will break, that's inevitable, and broken computers can't affect a dispatcher's ability to dispatch. And that is an element that high availability will allow you to achieve. And broken computers need to be fixed while the dispatchers are still dispatching. All these are components and advantages to using a high availability server infrastructure. So, what are some of the benefits of using these clusters? And when we talk about clusters, we mean a series of three servers that are together either on prem or we're talking about nodes that are hosted within the cloud. High availability clusters allow for software updates and new features to be pushed without additional downtime to your system. A high availability cluster, even when fails, is still within an SLA because of the way the failover system works and how load balancing is achieved, which we'll get to here shortly. There's minimal loss of resources during this automatic failover. And with Enlite, clusters can be both hosted in the cloud as a service, say through a service such as AWS, or placed on premises air gapped. What are some of the elements of high availability? Well, let's just go quickly over load balancing. So load balancing is a technique used to distribute network traffic across multiple servers. Load balancing is often used by applications such as Enlite. By distributing traffic across multiple servers, load balancing helps direct the flow of traffic from a failed server or node onto the other nodes that are operating in parallel. In summary, load balancing is a crucial technique that helps to improve the performance, availability, scalability of the system by distributing incoming traffic across those multiple servers. And like it says here, it's easily deployed within an on-prem server cluster with Enlite or within cloud nodes. And it allows you to utilize budget-conscious servers in parallel to provide available mission-critical operations. And I was just going to get James to explain the formula that we see at the bottom.
It's math, right? So for those of you who come from an engineering background, this is a standard reliability equation for systems in parallel. So basically, what we're saying here, uh, I don't know whether you guys really need me to break down the math, but I guess I'll do it for you anyway. This is a probability equation. So 1 equals 100%. The little pi symbol means multiply all the things inside by each other, right? So the RJ is the number of elements in the system and what happens at one specific element, and it's the reliability of that particular piece, right? So let's say that we have a piece that is 99% available, right? So in order to run this equation, we would say, okay, well, 100% minus the multiplication of 100% minus 99%, right? So that would be 0.01. And you can see that now we have like 99% here. Totally makes sense, right? Well, what happens if we had two nodes, both of whom are also 99%? This is where we start picking up our extra nines, right? So that equation is actually 99.9%. 0.9 again as a third node. That's where we get our fourth node, our fourth 99% from. And the equation continues on that way. And what you can see very quickly is adding a few reliable nodes, not even super high reliable nodes, but just adding extra nodes makes the system vastly more reliable.
Thank you,
Does that make
James.
sense, Nick? Woohoo!
Yes.
Again.
And we're just going to do a quick overview of data replication as well. So data replication allows for this automatic failover and the greater fault tolerance that you can expect with a high availability architecture. It helps prevent data loss in the event of a hardware failure. And how it does it here is data is monitored to ensure that a database stays consistent between the nodes as data flows from a primary node to the ones that are taking the copies of that as well. And now we're just going to go over some high availability best practices. So, to achieve geographic redundancy, geo-redundancy is a crucial line of defense against the outbreak of natural disasters that can lead to service failures. This practice involves deploying numerous servers across different geographical regions, thereby spreading the risk and allowing the architecture to fall back on a different server should a natural disaster strike. It's important to use failover solutions. High availability architectures usually involve numerous coupled servers that provide failover capabilities. A failover is seen as a backup operational mode that is automatically utilized when the functions of a primary system go down. It's important to implement load balancers. As mentioned previously, a load balancer will spread incoming traffic across different servers to mitigate the risk of any downtime. And it's also crucial to ensure that your data synchronization meets your recovery point objectives. RPO is the marker for maximum amount of data you can lose without causing harm to your organization or agency. This highlights the data loss tolerance of your business as a whole, and it tends to be measured in time units. So let's say 1 minute or 1 day. So if you need a backup or your tolerance is say 1 minute, you can't go any more than that. You got to ensure that your backup is happening once every minute, or if it's once a day, then it's once a day. We're going to review the high availability failover sequencing. So we'll start off first by reviewing the hot standby failover, which is a traditional one we're pretty much used to here. Number one, the primary ILS or core fails. The secondary peer server is instantly promoted to primary. And the secondary, now primary server, continues operation from the mirrored system database. And this is something that our traditional DCS system has used and something that we are able to achieve as well coming up in Q3 of 2023 with Enlite. Now we're going to just review the sequence failover for high availability. So just like before, a primary server fails. The first server to notice asks if it can be a primary. The other servers vote with a response of yes. A majority vote count is received, and the voted server switches to the primary. And this all happens seamlessly if a node did fail. We are also going to just go over a few different of the deployment options for Enlite, which include enterprise on-prem, cloud hosted, and hybrid. The Intertalk Enlite cloud hosted and hybrid architecture consists of an on-prem ILS/DCS dispatch Intertalk dispatch console system core connected to a cloud hosted, typically Amazon Web Services, Enlite cluster. The on-premise equipment securely connects to and communicates with the cloud Enlite cluster via SSL encrypted traffic. A network firewall appliance and static public internet IP connection are required to ensure continuous, secure communication. Some of the advantages to using the Enlight hosted architecture include the cloud hosted Enlight provides the best architecture for internet connected remote console positions. It is very easy for Intertalk support to do regular maintenance, updates, and monitoring of your system, and offers, of course, load sharing and balancing across the active servers. Now, this is one that we don't have currently developed at the moment, but are working towards. The Intertalk Enlight Hot Standby on-premises architecture consists only of on-premise equipment with no cloud component. The ILS Enlight applications do run on the same server. This architecture is considered to be one of the more common back-end equipment redundancy architectures that we have seen, where only one server is active at a time. So we have an active passive type situation, and all other servers are on hot standby with automatic failover. One server acts as the primary ILS, while the other is prepared to take over in case of failure or service disruption. Some advantages to using an Enlight hot standby architecture would be the fact that it is an industry standard architecture that your clients may continuously ask for. The level of redundancy or the number of servers can be easily controlled, and geodundancy is easily achieved and something that we all agree on. You have your primary, and then you have your secondary hot standby set up ready to go in case of failure. So, in conclusion, high availability is one aspect to your overall system resilience. Enlight hosted utilizing high availability architecture will allow for monitoring and updates with minimal downtime. It provides a clear path to meet the requirements of your service level agreements. Replication allows for automatic failover and greater fault tolerance within a high availability server architecture. And Enlight truly does give you the flexibility of your users to choose how they want to deploy and gives migration paths from, say, a totally on-premise system to the cloud for when they're ready. And that is pretty much everything here today. We're at the Q&A. I just wanted to open this up to anybody here to insert any questions, or if you'd like to chat, just raise your hand and I can get you in here and we can answer any questions you might have. And the raise your hand button is just over on the side.
So I guess this is a time to just do some general chit chattery.
Yes, sir.
Nick, I think that was really good. I know we were talking about high availability architectures and hot standby architectures, right? And I'm
Yeah,
surprised nobody asked the obvious question. Well, why would you choose one instead of the other?
exactly.
We kind of seeded that, but so I'll ask it of myself, James. Why would you do that? And I think the reason that we want to see this is twofold. If we go back to our parallel equation, if we go back to that reliability equation, we can see that adding more things makes a more reliable system. With a hot standby architecture, though, we only have one more thing. We can't add another thing, right? So one of the problems with the hot standby architecture is that you're kind of constrained to two, right? You can't go 3, 4, 5, 6, 7 to reach these higher levels of availability that we want to talk about. The second one is a really interesting technical problem that we call split brain. So often systems don't fail easily. And I'm sure as anybody on the call, if they've got experience with system design and systems in operation, nothing is ever working according to plan, right? If it does, it's a bit of a miracle. We all get really excited. But generally systems fail in awkward ways, right? One of the awkward ways is where the two parts of a hot standby system both think they're in charge, right? So again, we call this split brain. So both primaries are operating, both primary databases think that they're in charge, and then the system partition changes. And now the two primaries have to resolve the data that they've been misapplying to each other as primaries, right? So, you have this cross database synchronization problem. And then all of the clients that are affected, right? So now if you have a system like Intertalk's Enlight or Intertalk's DCS system, we connect. And so some of the clients in a hot standby architecture in this particular failure mode are connected to one side of the cluster, and some of the clients are connected to the other side of the architecture, and they don't interoperate as they ought to. And then getting yourself out of that is a significant maintenance operation, right? Because the data's been corrupted. We talked about that poison pill. One of the ways that poison pills happen is through hot standby architectures in split brain scenarios. So um, the idea is, instead of having two very powerful computers, let's have three, four, five less powerful computers. But because we have the smaller amount, we're able to take advantage of that reliability equation in order to achieve these higher levels of availability, right? The other cool part is of some of the HA configurations with load balancing is that we can share some of the load. So the application's performance improves when there are all the nodes, and then it degrades rather than hot switches from one side to the other during a failover. And again, we can have, let's say, 5 nodes, right? So now in that architecture, we can lose 2 nodes anywhere, and the system can degrade, but then it will continue to operate as if it was spread over a 3-node cluster. So our reads are a little bit faster, the applications are a little bit snappier, and everything is just kind of less urgent when a high availability system ends up losing a node or a piece of hardware.
Thank you, James. And I did have one question that was pre-submitted regarding geographic redundancy with the high availability architecture,
Mhm.
and just asking, can these nodes be separated from each other, or do
Sure.
they kind of stay together at one site and we have another cluster at a secondary site? I think that's kind of what they were trying to get
Sure. Yeah.
at.
So
Okay,
you get all sorts of interesting configurations with the Enlight infrastructure, right? And it's really going back to that disaster planning, availability, reliability. How much do you need? And then budget, right? Because going back to this basic reliability question, we can just throw more things at it, right? So we need more hardware or we need more performance, throw more things at it. We need more availability, throw more things at it. We need any of these things can just be adding more. So the interconnects between them are the limit, right? And we want to see a virtual distance that's pretty close, but it doesn't have to be a physical distance, right? So it's all about the high speed interconnections between things, right? Some customers have the ability to have very high speed connections with vast geographic distances, right? Think like your telcos. Your some can have only in short areas. If you kind of have like a secondary and a primary in terms of your single disaster recovery planning, your secondary is often not used in this situation. So you have a classic hot standby building, right? That there's no people in it, but it's there and it's ready to go. So now your disaster recovery, when the primary goes down, is significant, right? You have to move all of your staff to the secondary site. You have to make sure that everything still works. Sometimes sophisticated organizations will actually say, hey, great, we'll take all of our staff and just kind of randomly distribute them. So some days all of the staff are at site secondary, and some of the days they're all at site primary. And that's how we make sure that the fire alarm works during the emergency, right? Or in the case of the disaster, if the disaster strikes, we're all prepared. So because we just care about this network distance, you can have 2 nodes in one place and 1 node in another. You can have 3 nodes in one place and 2 nodes in another. It really depends on what exactly you're trying to mitigate, right? So if the mitigation is, well, what happens if one of the servers goes down, right? Well, the server that is in the primary area is able to lose an extra server, right? So you kind of have this bias to the primary area, even though in a failure situation you can spread the load over the over both geographic sites. If you lose the primary, though, you lose the majority of the cluster, and you have to then say, oh, okay, there is an automated or a manual, kind of big switch that says the secondary site that is thinking that it is in a minority and it can't vote to figure out who is supposed to be in charge. We know better because we've seen the big site go out. We're going to flip the breaker, and the secondary site is now going to be live. Very similar to what you would do in a geographic failover between a primary and a secondary that was like a legitimate disaster. Does that make
Awesome.
sense?
Absolutely. Thank you so
The other,
much, James.
but the other cool thing is now you can have 3 sites. You don't just have to have 2 sites, right? You can have more than just that hot standby. You can have 3 sites. And then if you look at your disaster recovery, you're like, wow, what are the odds that all 3 sites are going to go down? The answer is pretty low. It goes back to a reliability equation, right? Even better, they don't have to be as expensive. So having 3 sites is as something that is more achievable if you say that each site doesn't have to be super bulletproof because the sites are designed to go away.
Is there any questions regarding what James was just going over there? Please raise your hand if you do have any. Oh, no, I think we're good.
So
Well,
quiet.
It is. Well, I just wanted to give some feedback here. So, just to let you guys know, this webinar is being recorded and will be available to those with access to the dealer portal on our InnerTalk website as an on demand. Uh, as well as you're going to be receiving a survey today, just asking how the experience was, just to give us feedback so that we can keep tweaking these presentations and make sure that we're giving you the information that you need to sell our products and to make sure that we're meeting the demands of our clients. So once again, I give you guys a bit of your time back today, get about a half hour back. I really appreciate you coming here today. James, do you have any final words or
No, just that, in this new era of Zoom meetings, it's always hard to find the mute button fast enough. So thank you very much, everybody. Obviously, we're really excited about what we're doing here. Thank you very much, Nick, for all the work you've done to put this webinar together. And as always, if anybody has any questions, just reach out and we'll make sure to answer them for you.
absolutely? And like I said, our contact information will be on the survey that goes out. And I just want to wish everybody, I hope you have a great Wednesday. We'll be talking to you soon. And thanks again.